So this is my demo video for project 4 virtual reality, and I'll be giving the project demo here. So what is this project about? In this project, I have designed a virtual reality based training lab for autonomous vehicle training. And as you can see from here, there are three agents, or you can say three cars, red, green, and blue. And there is this roundabout turning scenario with four different roads cross away and a small traffic light present also. And this is based upon the reinforcement learning, Q learning based approach in order to train the discrete autonomous vehicles in the scenario. And there can be many different scenarios that you can play out. I'll go through them one by one and explain them to you. And before moving on to the scenario, I would like to explain the virtual reality based stuff for this project. So first things first is this walk around mode. So by default, I'm in the walk around mode, where if I tilt my head, so the view also gets aligned in that way. Using my left joystick button, I'm able to walk around this lab. As you can see from here, I'm able to walk around. So this is the default mode that can be used in order to navigate in this lab. And there are four different camera angles as well, which can be used while the training is happening or a simulation is happening. So in order to navigate to those, you need to click on the right joystick button. So I'm clicking on it now. Right. So this is the first person view for the simulating and simulation environment. I'll click the right joystick button again. Okay. This is the top view. As you can see, this is the top view for this training lab. I'm clicking the right joystick again. Right. So this is the in-person view, where if, for example, you are present in person on that road, that how the scenario would look like. This is that in-person view where you can see there is this red car, blue car, and the green car, and the small traffic light. So you are actually present at the crossing near the traffic light. This is how it would look like. And I'm pressing the right joystick again. This is the car view, where I'm right now present on the red car. I can move to different cars as well. Now I'm on the green car, and now I'm on the blue car. So this is the fourth camera angle that you can have in this training simulation. And on each car there are several metrics that has been mentioned. I'll come to those metrics later. I'll go back to the default walk around mode. This is the walk around mode which I'll be using for this demo. And one more thing, if you go leftwards or rightwards or using the right joystick, you can change the camera angle by staying stationary and not tilting your head. So this is one more functionality that has been implemented by me for this project. So yeah, now moving on. As soon as you start this project, this dialog box appears where it mentions that what is this project about, etc. How it uses reinforcement learning, Q tables, etc. for doing the simulation where the autonomous vehicles can be trained depending upon the scenario that we give. And as the project has this requirement for integrating some sort of AI service to it, so for that I've used Claude API calls and OpenAI API calls. The purpose of using a OpenAI API call was to cater to its Whisper service, which is used to transcribe the voice command into a particular scenario that we want to generate. And the Claude API calls is mainly used in order to generate a summary for a particular scenario when it's done before and after of it. That's one use case of Claude API. Second use case of Claude API is that the ARIA, the agent, the anomaly detection agent, it is actually backed by Claude API. So whenever any anomaly happens, it uses Claude API calls in order to reason out, and it generates a suggestion for us, and we can approve or reject it. I'll show that in demo. So that's one more use case of Claude API call. And third use of Claude API call is in the generation of custom scenario. So if a user want to build an altogether new scenario from scratch, and he would describe that, create the scenario, this and that. So Claude would reason based upon its requirement given, and it would generate the weights that would be implemented for each of this red, green, and blue agent accordingly. So for that, Claude's reasoning capabilities has been used. So now I'll start with the project demo. Where okay, so there are several scenarios. I'll come to them one by one later. There are 8 built-in scenarios that you can play around in order to train your simulation environment here. And but the thing is, what if a user comes and he wants to uh, you know work on a new scenario which is not present in any of this? Like in any of this, if you go through it's never a scenario where green and blue are aggressive, where red is super cautious. So if, for example, user want to do that or any other thing which is not present here, how he would do that? So for that, I have had this custom scenario help. So if you press B, move here. If you press B, so this is the custom scenario creation. You can. So I'll now go through the built-in scenarios which are present in my project. So there are 8 built-in scenarios that are present. So first is the baseline, where all the agents are backed by default weights. There are scenario focus is a reference behavior, and weights for red, green, blue are moderately safely aware. As you can see, this is the baseline. So all these weights are, they're unchanged from the baseline, and it also explains that what policy effect it expects it to have, what things to watch for, etc. This is the baseline scenario. The second is the red aggressive scenario, where we are making red super aggressive. How we would do that? So for that, the weights from the baseline for red has been changed. As you can see, the CA, TC, SM, and FP values of red has been changed. Blue and green are kept the same. And the expected policy effects: red more willing to accept collision risk, more willing to violate lights, and more speed seeking, etc. So this is the second scenario. Similar to that, blue is overcautious in third scenario, where the weights of red and green are same, where the weights of blue are being changed accordingly to make it super cautious. S3 three personality, where one is aggressive, one is cautious, and one is unchanged. S4 the anomaly area based anomaly detection. S5 fleet efficiency. S6 policy conflict. S7 persistent memory. So these are several scenarios. I'll give a demo for which one should I choose? Okay, I'll give the demo for S5, the fleet efficiency. This is somewhat complex. So all agent emphasizes forward progress for maximum circuit throughput. Scenario focus pushes fleet-wide forward progress to study throughput versus the safety trade-off. Here, red, green, blue, all are moderately safety aware, moderately safety aware, and moderately safety aware. So Claude reads the S5 as a throughput push, speed and forward progress was raised to study efficiency versus the safety. These are the weights that has been given from the baseline. This is taken from the baseline. So I'll go with this scenario. I'll press A. Okay. All legend emphasizes forward progress for maximum circuit throughput. This is the overall fleet efficiency. This is the baseline reference, the selected scenario, the weight delta from the baseline, and the expected policy effects. If you are in a technical details for it, you can pause this video and read it on. The CA stands for collision avoidance, TC is traffic compliance, SM is speed management, and FP is forward progress. This is the observation checklist, the AI contribution, and recommended reviewer workflow for this project, for this scenario. Now I'll start this scenario. ARIA procedure, some sort of anomaly detection. What anomaly will it detect? Agent Blue has run 6 red lights due to insufficient traffic compliance during its decision-making algorithm. Okay. Current policy state, it gives us the red, green, blue current policy state for CA, TC, SM, and FP. And using Claude, its reasoning capability, ARIA does its implementation where it is suggesting us to increase new traffic compliance from 0.3 to 0.65. Okay. And this is the expected outcome that it turns out that you will stop at red light and safety violation while maintaining usable freedom. Okay, this sounds good. Let me approach it by pressing A. Let's do the red agent and the red light okay. Now it's saying us to increase red traffic compliance from 0.0 to overall area to identify. Okay. So we need to approach this. This is all ARIA. Green agent ran 4 attacks into injection traffic compliance leading to only 0.3. Okay, so this is what we detected. What I call is basically the green traffic compliance from 0.3 to 0.6 plus what it is suggesting. As you can see, I can approve or reject it right now. But what is you can see from the display here, it has stopped at step number 400. It will not move on with the input to learning the training part or testing part. As long as I am not talking about the solution and activity giving me for this particular step. And the different SPA TCSS guidance at this step for all these others also giving this step 5. This is the live table that you can also access to. And on start, start can at this particular step what's the confidence level of the lab test in the TCSS for the system. So let me move on and press the for approve. Yeah. Okay. There's aggressive rate agent has been compared. Why this matters? This creates a direct process between the impatient aggressive agent and overly defensive agent in worst-case traffic condition reasoning of true learning and extreme behavioral mismatches. Okay, so this is what Claude has given us some sort of reasoning based on the data that it is true. As you can see from the live people here, it has stopped at step number 600 and is now updated by the storage. And so, for the base and after if approved is to the base, okay, if you are into the technical details of it, you can verify it on your own, or if you want to just proceed forward, you can do it. Okay, red agent red ran three red lights to extreme low traffic compliance, receiver maximum compliance with very low popular speed, maximum setting. Okay, what is this? So the same reduce the rest red traffic compliance from 1 to 0.7, the rest which is improve this. Legend continues to okay. Even after changing the red values, usually it is showing some sort of compliance violation. So the solution to increase the traffic compliance to all the maximum of okay. Let's follow these two systems. Scenario complete. They have mentioned test aggressive relation and these are some technical details for all this how the scenario played out. And this is the plot and this is summary. And this is how the scenario would look like if you approve all of the suggestions. And given it has completed it in 900 steps, so different values would look like. Uh, this is one of the demo. I'll go back to the scenario browsing. Let me select any other scenario. Let's say at 3%. Okay. So now I'll give the custom scenario description that how it happens. So till now we were browsing through all this 8 scenario that has been integrated in this application. But for example, if some user comes and he's like, I don't want any of the scenario, I want something of my own. We want to test it out, right? So how would that happen? So for that we have this custom scenario help where if you press B, let me move here. If you press B, so you can ask ARIA to create a custom scenario instead of using a preset. ARIA is backed by Claude, so the Claude would help to reason out that what weights to have, what scenario generation things to be built out. All these things would be handled by Claude, and for that you need to press right trigger and say create a scenario. So in all those integrated scenarios that we have, there was none of the scenario where green and blue is aggressive, where red is super cautious. You can think of anything else as well. So for testing this, I'll give this as a custom scenario. sending audio to whisper, writing the transcript, ARIA designing scenario. Green blue agent drive aggressively while red agent is extremely cautious. So it detected it perfectly before. These are the baseline weights. After if we prove these are the weights based upon the scenario that we just gave, and I think it looks good. So let's approve. Next, add step number 2 to that. What is this suggestion? Okay. So red agent vaccine like into the insufficient traffic compliance. Yep. Okay, increase the traffic compliance from this, but the evidence and overall the behavior is expected outcome. Okay, so this is all reasoning that has been done by Claude. And approve this. Let's see. Okay, something else. Weakest against the identical. Okay. Other recommendation: increase safety motivation from 0.2 to 0.6 to make the red prioritize safety, stopping over the aggressive behavior. So I okay. So this was the custom scenario. These are the technical details at each step, at step 200 and step 800, and we approve both of them. And based on that, the scenario is laid out. And this is the plot generated summary. You don't want to dive deeper into the also without the summary of what happened. This was a custom scenario. This is not built in the application. It was entirely by me. Plot generated the scenario for back to ARIA back by Claude. It gives us the model base, detects the anomalies, gives us a suggestion. If you approve or reject it, it plays around those things, that plays around the reinforcement learning project team that thing. So this was public presentation for So I'll now first showcase the scenario with you. Okay. I'll now for the two demos that I have shown till now, I've approved everything that ARIA was suggesting me. So now let us select this scenario where it is. Let's say mm, let's say we choose the three personality scenario. Okay, move on. This is all the technical detail it asks for. This one that is doing it up. Suggesting us something. Okay. Test how many agents there are there. Okay, ARIA recommendation. Increase blue traffic compliance from 0.8 to 1 to ensure that traffic obeys another. Till now, I was approving whatever ARIA was suggesting me. What if I reject it? I'm pressing B. Okay. ARIA processing for this scenario. Okay. Increase blue traffic compliance from 1 to 1.5 and then okay, let's approve this. Okay, now. Decrease speed management essence from this to this for college. I want to do this for sort of agent. I don't want to do that. I want to reject this. I'll reject this. What is not happening. Okay. After rejecting it, it is now reevaluating and it found out some different solution that can happen as we rejected the second proposal that it had. It increase the red traffic compliance from this to this to strengthen the volume positioning and the area. Okay. Now I'll approve this. Okay. After approving, see now you can see at step 200 we approved, step 600 we rejected, and step 800 we approved. So this is how the scenario played out. Why this functionality was implemented by me because the user can have different edge cases that we want to test out. We want to approve or reject. It's not always gonna be approval for all the recommendations that we suggest, right? So this is one of the functionality that I would like to showcase. And again, the plot generated summary that whatever happened before and after the scenario, how did it play out, etc. has been also given here. If you're not much into the technical details of it, you can read the plot summary to understand what was actually happening. Alright.